Everyone. In last few lectures we have completed our chapter 1 and chapter 2, that is basics of thermodynamics and temperatures. In this lecture we will solve some questions based on those two topics. Okay, so let's start with the question number 1. So the question number 1 is: a closed system is one whose boundaries allow. You should remember that we have discussed three types of system. First one is closed, second one is open, and third one is isolated. Okay, when we studied about closed system, we discussed that since the system is closed, there will be energy interaction, but there won't be any mass interaction. Okay, the closed system whose boundaries allow only energy transfer, only mass transfer, both energy and mass transfer, none of the above. So the answer will be only energy transfer. Okay. Now the second question: the zeroth law of thermodynamics deals with. In when we studied the zeroth law of thermodynamics in last lecture, I defined that the definition. I have used thermal equilibrium term there. So what is mechanical equilibrium? The equilibrium of all the forces, external forces acting on the system. Chemical equilibrium is there should be no reaction, no chemical reaction in the system. Thermodynamic equilibrium consists of all these three. Okay, but when we studied zeroth law of thermodynamics, we only discuss about thermal equilibrium. That is the temperature of the body. Okay. Next question is a thermodynamic property. So thermodynamic property depends on the past history of the system. Does not depend on the past history of the system. Can have different values when the system is in particular state. Depend upon the how the system worked in that state, none of the above. When we studied about property, we discussed that the property is a point function. Okay, so the thermodynamic property does not depend on the path history of the system. Okay, it only depends on the initial and final state. Like if we have to calculate the change in entropy, then we will just subtract the entropy values from both the points. Next is: which of the following are pure substance? We discuss the pure substance. So let's first see about gases here. Air is a pure substance. We have already considered in the examples. One of the example, the mixture of gaseous air and liquid water. So this is not a pure substance, because if we consider as discussed, if we consider, let me make it here. So this is liquid water, and this is air. Okay, so if we consider three different samples, so in these three samples the chemical composition is not homogeneous throughout, so this is not a pure substance. A mixture of liquid water and water vapor, this is the pure substance. We have already discussed in one of the example. The mixture of gaseous air and oil, this is also not a pure substance. So the question was which of the following are pure substance. The answer is 1 and 3. 1 and 3 is in option number D. Okay, next question is: which of the following statement regarding the concept of continuum is correct? We are talking about concept of continuum. So the first option is: large number of molecules enable meaningful statistical averaging and assignment of the property value. So this statement is true. As you can see, if there are large number of molecules in the system, then the statistical averaging will be meaningful, and we will be able to properly assign them the values. Mean free path of the molecule in order of magnitude higher than the system dimension, this is incorrect. We have discussed that mean free path must be very less than the magnitude of system dimension. Okay, behavior of the individual molecule is disregarded, this is correct. Mean free path of molecule approaches the order of magnitude of system dimension, this is incorrect. So the answer is 1 and 3, option A. Next, for a ammonia water mixture system existing two phases in equilibrium, the number of independent property required to fix the state of the system. So here we will be requiring Gibbs law. Okay, so what is Gibbs law? P plus F is equal to C plus 2. So in question, how many phases are there? It is mentioned at two phase in the equilibrium. Okay, so two phases. We have to calculate the value of F is equal to C components NS3 and water, two components plus 2. So we get F is equal to 2. So we require minimum two states, two properties, two independent properties to fix the state of the system. Next question is, which of the following are intensive properties? Okay, so if we talk about intensive properties are those which will be independent of mass. Okay, so let's talk about all the options. Energy, energy is not an intensive property because it will be dependent upon the mass of the system. Volume is also not an intensive property. So these both are not an intensive property, but pressure is intensive property. So is the specific enthalpy. So answer will be 3 and 4, option C. Okay. So next question, a single fixed point temperature scale is based on. So we discussed in last lecture that single point fixed point temperature scale is actually our Kelvin scale, which is based on triple point of water. Okay. Next, in the following shown a schematic of thermal power plant, the closed systems and open systems are identified correctly identified as. Okay, so here this is our total of thermal power plant layout. So we can see that in all the parts, like whether it is turbine, condenser, pump or boiler, there is entry and exit of mass. Okay, mass is continuously entering and continuously exiting. So these all four systems are, what are these all four system? Open system. So let's see the options. Turbine, boiler, turbine, condenser and pump are open system, and overall plant is a closed system. Yeah, absolutely true. So if we consider the overall plant, then let's say this is the system boundary. Okay, system, this is system. So there is no no flow across the system boundary. Okay, so this complete overall plant will be a closed system. So option C will be correct. Next question is, a system is partitioned into two equal parts, and intensive property of each part will be. So as I have mentioned earlier in the last few lectures, that the intensive property, if we divide the system into two, will remain unchanged. Okay. Next is match list 1 and list 2 and select the correct answer. Okay, so let's see a jet engine in a flight, water being heated in a sealed container, internal energy, specific entropy. Okay, so let's say the water being heated in a sealed container is an example of closed system. Okay, open system, let's say the jet engine in a flight, so the continuous flow of mass, okay, in and out of the system, so this is the open system. Internal energy is an extensive property because it will be dependent upon the mass, and specific entropy will be intensive property. Okay, 2143 option C is correct. Next question, let's talk about question number 12. A new temperature scale, degree P, the boiling and freezing point of water in at 1 atmosphere are. So as I mentioned earlier, let's draw two lines here. Okay, so this will be for degree P, this will be for degree Celsius. Okay, so in degree P it is mentioned that 100 degree P is ice point, and if the boiling and freezing point, okay, sorry, so freezing point is 300 P, boiling and freezing point are respectively, it is given na? And the boiling point is 100 degree P, 100 degree P. Okay, and similarly if we talk about the water, the boiling point is 100 degrees Celsius and 0 degrees Celsius is ice point. Okay, so correlate the scale with the centigrade scale, the reading of 0 degree P in cent. Okay, so it is mentioned that if the temperature is 0 degree P, what will be the value in degree Celsius. So we will, let's consider a line here P, here it is C. So we will or let's say it TP and TC. We will write it as TP minus 300 upon 100 minus 300 is equal to TC minus 0 upon 100 minus 0. So we can, from here we will get TC is equal to minus 1 by 2 times of TP minus 300. Yes, that's it. So here we have been asked the reading of 0 degree P in the centigrade scale. So for 0 degree P, if Tp is 0, so our Tc will become minus 1 by 2 into minus 300. So this will be our 150 degree Celsius. So answer D will be the correct answer. Okay, so next, which of the one of the following correctly define 1 Kelvin as per internationally accepted definition for temperature scale? So as I mentioned in last lecture, 1 Kelvin is 1 upon 273.16 of the triple point of the water. Okay. Next, which of the thermometer is independent of substance or material used in construction? It is very important one question. So as I have told you that it is a ideal gas thermometer which is independent of material of the construction or the substance which is used. Okay, triple point of water is 273.16 Kelvin or 0.01 degree Celsius. Okay. The following are the example of some intensive property and extensive properties. Okay. So the pressure is, let's talk about pressure is intensive, temperature is intensive, volume is extensive, velocity is, so when we talk about velocity in any part of the system, velocity will remain same, so it is also intensive. Okay. Electric charge, if we talk about system, okay, so the electric charge is independent of the mass, so it is the extensive property. And similarly, potential energy is mgh, it is also extensive property. Viscosity is intensive property, which is because it is independent of mass. Okay. And magnetization is also extensive property. Okay. So the correct option is 1, 2, 4 and 7. This is the correct option. Okay. Next question is match type and thermometer. We have to match type of thermometer and with thermometer property. So mercury in glass, here we will like measure with the help of volume or length, we can say. Okay. Thermocouple, it's based on the voltage. Yes. And thermistor, we will use electrical resistance and constant value with the temperature. So the answer is 3, 4, 2, 1. 3, 4, 2, 1. Option D correct. Okay. Next question is, if an alcohol and mercury thermometer read exactly at 0 degree Celsius and 100 degree Celsius, and the distance between the 2 points is divided into 100 equal parts in both thermometer. So let's say if an alcohol and mercury thermometer, there are, so it's question it is a question like this. There is a alcohol type thermometer here. Okay. And there is a mercury type thermometer. Okay. This is the mercury type thermometer, this is an alcohol type thermometer. Alcohol. Okay. So it is mentioned that thermometer read exactly 0 degree Celsius. Okay. So this is, so it what is written here that read exactly at 0 degree Celsius, 100 degree Celsius. It means that it is calibrated when when we make a thermometer, we have to calibrate it at like 2 different points. So we have calibrated it at ice point and steam point for both. thermometers. Okay, so both temperature will show same temperature, same value at 0 degree Celsius and 100 degree Celsius. Okay, so we after that it mentioned that the distance between 2 points is divided into 100 equal parts. That is, it is further divided into 100 equal parts. Similarly, this is also divided into 100 equal parts. Okay, but next point it is mentioned that the two thermometers will give exact same reading at 50 degrees Celsius. When we make a reading at 50 degrees Celsius, so it is written here that it will be give the same reading. So it won't give a same reading. First of, listen well. Like this is alcohol and this is mercury. This is not an ideal gas thermometer which will be independent of material. Due to the material of construction, like let's say this will show something below and this is say something above, or in similar manner, like both won't show the same temperature. Okay, 0 and 100 degrees Celsius, they are showing the same temperature because they are calibrated at those point. Okay, but if there is in between point, then it won't show the exact same temperature. Okay, and the temperature scales are arbitrary. The because reason is because the temperature scales are arbitrary. All the temperature scales are arbitrary, so they can't show like the exact same reading value. Okay, so here the option A is false but R is true. Okay, option D. Okay, so next question is let's talk about question number 20. Question number 20 says the new temperature scale degree N is to be defined. The boiling and freezing point on the scale are 100 degree Newton and 400 N respectively. What will be the reading of scale corresponding to 60 degrees Celsius? Okay, so similarly as we have done this question, it is this one, we will proceed with this question also. So the question number 20, we can proceed as, let's say, these are the lines for ice point and boiling point, and this is a reference line, intermediate line. Okay, let's say this is ice point will be 0 degrees Celsius, 100 degrees Celsius, and let's say this is corresponding to 60 degrees Celsius, which is asked. Okay, so here it is mentioned, and boiling and freezing points respectively. So boiling is at 100 degree Newton and freezing at 400 degree Newton. Okay, and here the value is some Tn, let's say. Okay, so we have to calculate the value of Tn. What will be the value of Tn? So we can directly use the ratio thing, the ratio formula I told you earlier, that is, let's say, 60 minus 0 upon 100 minus 0 is equal to Tn minus 400 divided by 100 minus 400. Okay, so this will give us minus 300 into 60 upon 100 is equal to Tn minus 400. So the value of Tn is equal to, you will see the value of Tn, this will be 120 degrees, 180 degrees, and this 180 400 minus 180 will be 220 degrees N. Okay, so this will be the answer for question number 20. Let's see, in question number 21, it is mentioned that at what temperature both Celsius and the new temperature scale defined in our question read the same value. Let's say that they read the same value at some temperature. Let's say at temperature Tc, at some temperature Tc, they Tc and Tn will both be equal. Okay, so we can write Tc minus 0 upon 100 minus 0 is equal to Tn minus 400 upon 100 minus 400. If both temperature scales are equal, so we can say like let's say Tc is equal to Tn is equal to T. Okay, so we can say 300 minus 300 T is equal to 100 times of T minus 100 into 400. Okay, so we can solve it like this, and we can get 4T is equal to 400, T is equal to 100 degrees Celsius. So we can also see here 100 degrees Celsius and 100 degree N are both equal. So T is equal to 100 degrees Celsius or 100 degree N. Okay. Okay, so this is our next question. Question number 22. The reading TA and TV of 2 centigrade scale thermometer A and B graded ice point 0 degree Celsius and steam point 100 degree Celsius are related by TA is equal to this. Okay, where L, M, N are constant, both are immersed in oil. Then thermometer A reads 51 degrees Celsius, thermometer B reads 50 degrees Celsius. Determine the reading of thermometer A when temperature B is 25 degrees Celsius. Okay, so both are graded 0 degrees Celsius and 100 degrees Celsius. It means, so let's draw our scale or leave the scale. So the equation is given is equal to TA is equal to L plus MTB plus N TB square. Okay, and it is mentioned that they are both graded at 0 degree Celsius and 100 degree Celsius. So T and TB value will be same at the 100 0 degree Celsius and 100 degree Celsius. So let's talk about at 0 degree Celsius. So when we talk about at 0 degree Celsius, we will get 0 is equal to L plus 0 plus 0. So we will get L is equal to 0. Okay. When we talk about 100 degree Celsius, again the both values will be same. So 100 is equal to value of L is 0 plus 100 times of M plus 100 square times of N. Okay, so we here we can get M plus 100 N is equal to 1. Okay, now the next point, it is mentioned that when thermometer A reads 51 degree Celsius, thermometer B reads 50. Okay, so third point is TA is equal to 51 degree Celsius and TB is equal to 50 degree Celsius. So we will also equate this equation. 51 is equal to L is equal to 0 plus M TBM, so 50M plus 50K square N. Okay, so using this equation and this equation, we can calculate, let's say M is equal to 1 minus 100 N. So we will substitute this here. So 51 is equal to 50 minus 5000 N plus 2500 N. Okay, so we can solve it and get we will get 2500 N is equal to minus 1. So N is equal to minus 1 upon 2500, and similarly we can get M is equal to 1 minus 100 into N is equal to minus 1 upon 2500. So we will get 1 plus 1 upon 25, that will be 26 upon 25. Now determine the reading of the thermometer A when thermometer B read 25 degrees Celsius. Okay, so we have got we get all the values, so we can write equation TA is equal to L is equal to 0 and M is equal to 26 by 25 times of m plus, sorry, this is value of m, so our TB, and this is uh, minus 1 by 2500 times of TB square. We will substitute value of TB is equal to 25 at both places, and we will get TA is equal to 25.75 degrees Celsius. Okay, so we get that determine the reading of thermometer A when thermometer B read 25 degrees Celsius. The reading will be 25.75, which is the correct answer. And next is, it is asked to comment on question which thermometer is correct. So if it is asked which thermometer is correct, so it is not possible to predict which thermometer is correct, because both will we have calculated both thermometer at on the basis of steam and ice point. So in between both will give different results. So we can't say which one is correct, which one is incorrect. Both may be correct, and both may be incorrect. Okay, anything may happen. So we will move to next question. Next question is, let's talk about this question. Okay, so here it is the question. Air in a well insulated room is circulated by 0.5 HP fan driven by 65% efficiency motor. Find the rate of energy supplied to the room of shaft power to the fan. Okay, so let's assume a room. In this room there is a fan. Let me make it again. There is a fan. Okay, and it is said that the room is insulated, so there is no heat loss from or to the room. Okay, and it is said that the fan delivers the air at efficiency of 65%, and another thing is mentioned that circulates at 0.5 HP fan driver. So, and it mentioned the motor delivers itne HP of net shaft power to the fan. So power at this shaft is 0.5 HP. Okay, here the important point is, since the fan power is given in horsepower, we can convert it into kilowatt with the use of formula 1. Horsepower is equal to 0.7457 kilowatt. Okay, and hence we can write 0.5 HP is equal to 0.373 kilowatt. Okay, so we can directly write it 0.746 kilowatt, and we get 0.5 HP is equal to 0.373 kilowatt. Okay, so if the efficiency of the so what is the efficiency? Efficiency is output energy upon input energy or power, whatever we can say. Okay, so output here, the output energy what we will output will be the rate of energy supplied to the room. Okay, so energy, let's say E is the energy supplied, and what is the power input? Power input is 0.5 HP. 0.5 HP, let's write here 0.5 HP, or we can if you want to use it in terms of kilowatt, we can write 0.373 is equal to 0.65. Okay, so we can multiply 0.373 with 0.65, and sorry, I mean here it is written the rate of energy supplied to the room, so the net rate of energy supplied from here, really from here. This is the horsepower. This power we can is obtained at the like soft power. Soft power. So this is the also be the blade power. So here power will be 0.5 HP. So we will make some adjustments. So output here is 0.5 HP, that is 0.373 kilowatt, and input energy is the energy supply rate. Okay, and it's applied to the room. So we can calculate 0.373 divided by 0.65. We will get efficiency is equal to 0.5738. Okay, or we can write 0.574 kilowatt or kilojoule per second efficiency. No, sorry, it is rate of energy supplied. Okay, so we have completed this question, and let's move to the next question. Next question is, this will be the last question for today's class, and in this question it is given a piston cylinder arrangement is shown in container. Sorry, give me a minute. Okay, a piston cylinder arrangement is shown in the shown below, contains air at 250 kilopascal and 300 degrees Celsius. Okay, this is the initial condition. The 50 kg piston has diameter of 0.1 meter and initially pushes against the stop. The atmospheric pressure is 100 kilopascal. Okay, diameter this, the mass kg piston, atmospheric pressure is itna 100 kilopascal. The temperature, so it is given that P node is equal to 100 kilopascal. Okay, and it is mentioned that temperature is 20 degrees Celsius. So the ambient temperature is equal to 20 degrees Celsius. The cylinder cools as heat is transferred to the ambient. Okay, so initially it is at right, like mentioned, 300 Kelvin. So it is mentioned that temperature, the cylinder cools as heat is transferred to the ambient. Heat is transferred to the ambient T node. At what temperature does the piston begins to move down? Okay, so what do you think? So when do you think that piston will begin to move down? So piston will begin to move down when the pressure in the system will be reduced, or when the downward force on the system will be more than that of the upward force. Okay, so let's draw the forces acting on the system. So this is our piston, and the upward force that is acting here will be 250, that is pressure into area. Area is pi by 4. This is mentioned as cylindrical piston. So pi by 4 into d square. D diameter is 0.1 meter. This itne kilonewton. This is the force, upward force that will be acting on the piston, and the downward force acting on the piston will be, let's say this is the downward force that will be acting, and we are talking when the piston will begin to move down. When piston begins to move down, the reaction force between the stopper and the piston will be 0. So there will be only one force downward, that is P node, atmospheric pressure into area, that is, or write it in this way, let P node into A. Okay, and area is equal to pi by 4 into 0.1 square, meter square. Okay, this is P1 and this is T1 is equal to this. Okay, so and here it is P1 into A. Okay, and one more force that will be acting, that is the weight of the piston. And how much weight is it? Is 50 into g mg. Okay, so piston will start to move down when the reaction force will be 0 and all these forces will be balanced. Okay, so P node A plus 50g will be equal to P1 into A. Okay, so we have to calculate what will be the temperature. Since we have already mentioned this pressure is P1, so we have to write it as P2, some final state, as the temperature of the air will decrease, or the energy will be transferred, the pressure here will decrease. And what is the final pressure? Let's say P2. Let me write it a different color. P2 will be the final pressure of the system. So here we will use term P2, that is the final pressure. Okay, and from this equation we will calculate what will be the final pressure. Okay, P2. So here P naught is 100 into uh, area, pi by 4 into d square, 0.1 square plus 50 g. And one more thing, since this pressure is in kilopascal, and we want P2 is also in kilopascal, so we can directly divide it by 1000 to convert the weight in kilonewton. Okay, so the calculation will be easy. So P2 into pi by 4 into 0.1 square. Okay, so let's write it, what we can see here. (50 into 9.81, that is G, divided by 1000. Okay, divided by pi into 4 divided by 0.1 square. Okay, plus 100. So we will get P2 is equal to 162.45 kilopascal. So this will be the final pressure of the for the arrangement. Okay, and at this pressure what will happen? The piston will start to slowly move downward. Okay, now what we have to calculate? We have to calculate that since there is the heat transfer to the ambient, the temperature will decrease, and we have to calculate what will be the temperature does piston begin to move. So we have calculated the pressure at which the piston begins to move. Now we have to calculate what is the temperature at which piston begin to move. So just when the piston began to move, you can see that volume of the system will be constant. Okay, like the height will remain the same. So from we can apply ideal gas equation here. PV is equal to mRT. So from here we can say that since volume is constant, just when the system is about to move down, the volume will remain same. So pressure is directly proportional to temperature. So we can write P1 upon P2 is equal to T1 upon T2. From here we can write 250 upon 162.45 is equal to T1. What is T1? T1 is given as 300 Kelvin divided by T2, which we have to calculate. Okay, so into 250, we calculated the temperature T2, which came out to be 194.94 Kelvin. Okay, one slight correction here. This temperature 300 degrees, mentioned 300 degrees Celsius. I mentioned it in Kelvin by mistake. Since it is 300 degrees Celsius, so this will be 300 plus 273 is Kelvin, and we will get our answer as 573 into 162.45 divided by 250. Okay, so we get 372.34 Kelvin, which will be equal to 99.34 degrees Celsius. So both our answers is correct here. So this will be it for the today's lecture. We have seen some questions on basics of thermodynamics and temperature. Okay, So thank you. In the next lecture, we will start with work and heat transfer. Thanks for today.